My name is Benjamin Webb, and yeah, I'm going to be presenting on unifying standards for water data exchange, specifically leveraging OGC API EDR, environmental data retriever, and pygeoapi. So a little bit about myself and my organization. I work at the Center for Geospatial Solutions, which is a technical group inside of the Lincoln Institute of Land Policy focused on helping organizations at the front lines figure out our most complex land, water, and social challenges. Specifically, I work on a project called the Internet of Water. So CGS is the technical engine for the Internet of Water Coalition. We are collaboratively funded by NOAA, USGS, Oak Ridge National Laboratory, and the US Department of Energy. So we have our feet in a lot of US federal agencies, and the goal is to modernize water data infrastructure in the US through common standards. So what I'm going to be presenting about today is really sharing the ongoing work in multiple OGC working groups. So principally this work is centered in the OGC hydro domain working group, but we are responding to and trying to coexist with other standards. So that is specifically the time series markup language standards working group and the observation, measurement, and samples standards working group. And the water data challenge is a big one. Water data comes from diverse sources, but lacks a significant standardization. Disparities in formats hinder analysis, sharing, and decision-making. And hopefully unified standards like WaterML2 and OGC API EDR hope to address these challenges. And a wise person said to me this morning, interoperability is a really big word because it can mean a lot of things in a lot of different contexts. And water data comes in many different types. It can be represented as geospatial features. So this is rivers, lakes, dams, catchments. It can also be as a time series. So, a lot of organizations have long-term monitoring of flow, quality, quantity of their water. But water data can also be represented through satellite images and remote sensing. And so figuring out a common way to represent all of these disparate data types and have them be interoperable is actually a really big challenge. So WaterML is an OGC standard that was adopted in 2012. XML is the serialization of choice, and it is a standard information model for the representation of water observations. XML is no longer the flavor of choice, and so the big work in the OGC working groups is how do we still represent the richness of the information in WaterML2 without the complexity. And that is in part because we're representing a really complicated thing. And so to give you some context on how all of these standards coexist, so observations and measurements predates observations, measurements, and samples, and WaterML was based on the original observations and measurements. And then time series markup language was derived from WaterML. So they all share a really intimate relationship. And I think what the big key realization has been is that there's no one common data format that can capture everything we need. And so I actually think it's really important to split the use cases for water data into at least two, potentially hundreds. So the first use case I'd like to think about is web app development for community education and engagement. So the primary audience we're thinking about in these contexts are community members, educators, local policymakers, not the people in this room, unfortunately. And what they need is something that is easy to use, that makes water data interactive and educated. And they also want to understand water and local water resources to help then further educate others. They are principally challenged with limited technical design and need for a web-friendly format because they're unlikely to be willing to download the data onto their machine and look at it in that way. So what does this mean for WaterML and the standards? The principal idea is to use OGC API EDR, environmental data retriever, for streamlined access into spatial and temporal data, enabling direct integration into web maps. and to leverage JSON for compact, browser-friendly data serialization, optimizing performance for web environments, and then to define a best practice and expose it and continue to use it. The other more complicated, serious use for WaterML is the scientific analysis for water resource management. So this is what WaterML was principally designed for, but WaterML needs to speak to all of the needs for all of the users of water. So this audience is researchers, water scientists, water resource managers, and environmental scientists. They want access to detailed, accurate information for analysis, and they care a lot about metadata. Their goals are to analyze water quality, monitor trends, and inform the policymakers about what is going on. What that means for them is that they need a complete model of WaterML. So they need it to include all of the metadata that is included in observation, measurements, and samples. And they also need to be compatible with time series markup language because we don't need 3 different standards for this type of information. They need to all be harmonized and interoperable. So what does this look like? Observations, measurements, and samples was recently updated. And so time series markup language 2 is being responded, as is water markup language 2, to find a representation that is compatible with all of these. How do we find one representation to rule them all? In the working group, we're talking about 3 potential representations of this: coverage JSON, OGC sensor things API, and CSV. I'm going to quickly pull out and acknowledge sensor things API because it's not actually a serialization. It is a logical model to relate different types of information, but it does still contain all of the time value metadata that is required for time series markup language and observations, measurements, and standards. What that means is that any data publisher that is choosing to publish their data through sensor things would theoretically be compliant with OMS as well as time series ML, and if their data is about water, it would also be compliant with WaterML. So in that way, we're really trying to unify multiple different standards and check the box for all of them. And is sensor things API really interoperable? No, because for every single field in that entity model, you could put a different piece of information. You could represent your data differently. And I have found that every single sensor things API endpoint I look at is a little bit different from one another. But it does expose a consistent logical model for relating a sensor, the data stream of data that's coming from it, and all of the observations. And that is a really powerful tool. And that is why one of the focuses for the development for the proof of concept from this OGC working group has been representing sensor things API as OGC API EDR in pygeoapi. So USGS operates a sensor things network of all of the stream gauges in the US, and we are able to represent that as OGC API EDR, thereby meaning that this endpoint would be compliant with what we're thinking of as observations, measurements, and samples, time series markup language, and WaterML. Why is EDR something that we like? Because EDR is a web map ready time series. So without needing to know the features of interest or the specific observations being measured, we are able to readily generate a web map of time series without the metadata of where the information was collected, without the metadata of provenance and all of the things that someone that is a data user really might need. But as an uninformed politician, this would be a really great way to see, the stream gauge height has risen and fallen in the last week, or upstream of me, they're releasing a bunch of water. What's important is EDR can also represent raster data. So this is the USGS PRISM model. So you can represent various types of data, raster, time series, through EDR. So similarly, just by querying the bounding box of the United States, I'm able to get a map of raster data that is tied to specific information. So as you can see here in the bottom right, Each of the values in this raster is tied to a specific degree centigrade that is the maximum temperature from that time period. And through this, OGC API EDR is able to capture multiple different types of water data in the same format. And even more, like I said, there are hydrologic features. So what if you were interested only in the gauges on a specific river? Through EDR, actually OGC API features is one of the components of EDR. So in EDR, you can query by multiple different ways, and features is built into EDR. So you can represent any item. And in this case, we're taking the Colorado River, and I'll ask you to notice here the permanent identifier for the Colorado River that flows through the Grand Canyon is geoconnects.us main stems 29559. And by going to this link, we're able to use OGC API features to only show us gauges that are on that main stem. So this is a QGIS link, but if I click on it and open it in pygeoapi, we're able to look at those exact same features and zoom into any one of interest. Through this way, EDR and pygeoapi are able to readily serve water data in an efficient manner. So how well are we doing? Do we have easy-to-use interactive water data for education and decision-making? I think yes. I think EDR and what we've looked at here does a really good job at answering that first use case. What we still need to dive into is figuring out how to access detailed and accurate water data for analysis and modeling. Should a user want to use the Sensor Things model, Sensor Things allows for really complicated queries where you can access all of your metadata and observations in one request. But making sure that aligns with WaterML is something that we are planning to do in the OGC group in the next couple of weeks and months. So recommendations of what to do from here going forward. We really need to develop modular standards that allow users to select only the components they need. In my mind, one of the downfalls of WaterML was that it was too complicated for the layperson to really use effectively. It was really effective at super precise, super exact information, which was really valuable for modelers or people who care about metadata, but translating that into a web map is a large task. We also need to continue to build tools and APIs that bridge across these standards. pygeoapi is a really great example of implementing multiple OGC APIs all in one common place. And this allows the seamless exchange of data across different platforms. We also need to strengthen the partnership between technical experts, data providers, and user communities to guide development and adoption. So like I said, I'm presenting work that is ongoing in OGC working groups. All of this is welcome for anyone who is an OGC member to sit in on the group and provide their advice. But really, the people in this group right now are technical experts. And the need for data providers and users to fit into OGC and continue to emphasize and advocate for their needs in the OGC standards is something I think is really lacking at the moment. Yeah, so I'm nearing the end of my presentation, but I have some links for further reading. For anyone who's interested in using the EDR provider themselves, they can go to pygeoapi plugins, which has the Sensor Things API EDR plugin built in. And then I'll also just show you quickly what an interactive EDR query looks like. So here we're querying by bounding box. I believe this is the Southwest New Mexico. And without knowing the type of data that is in the Sensor Things endpoint, only knowing our area of interest, we're able to get all of the observations in that area, and we're able to really easily put them on a web map. So, anyone in this room on their phone could go to this same website and would receive this same web map and would be able to say, oh, I wonder what the gauge height looks like at here in Roswell, New Mexico. And you can see observations up to, let's see, 2:30. So we're seeing observations from the last 45 minutes live in this Sensor Things endpoint. And you can just do the same for any different type of observation in your EDR provider. And so with that, I'll ask if there are any questions, and please reach out otherwise. Thank you.